Welcome to the What Circuit blog. We're going to kick ourselves off today with a review of the HAMEG oscilloscopes. It's the new range, the HMO oscilloscopes. We've got here an HMO2024, so that's a 4-channel, 200 MHz bandwidth scope. Pretty nice little thing. To give you a bit of reference, our point of view, so our reference point to this is we've been using Rigel oscilloscopes at home before, but through work we've used high-end Agilent scopes, LaCroix, pretty much most scopes. So let's run you through it. So this new HMO line, this is a competitor to oscilloscopes such as the GW Interdec 3000 line, and in particular the Agilent 2000 and 3000X scopes. To give you an idea, the list price of this is about £1,950 plus VAT in the UK. As a point of comparison, an Agilent mixed signal oscilloscope, same sort of thing, 4-channel, 200 meg, that's going to set you back around 2,237. 3000 series is going to be about £3,500. Right, so let's get it turned on. Power switch at the back, turn on, quick little boot up, and you'll notice it's actually ready to use very, very quickly, compared to something like the Agilent scopes where it's actually got, I believe it's a Windows CE operating system, something like that. So it's very, very fast to turn on. Screen size, you'll immediately notice that's actually smaller than the Agilent, but the usable screen size, so the screen where you have the waveform one, that's about the same size as the Agilent. The Agilent then has a bar down the side which has the menu. On this one, however, menu pops out and then you can hide it again. So it's a nice clear screen. I'm not sure how well it's going to be captured on camera, but it's LED backlit, it's very sharp, nice sort of colour gradients, all of that. And when you're using this in DPO or digital phosphor oscilloscope mode, very nice. You get a nice sort of idea of intensity and how often your signal's coming through. Got a sine wave up on here. Let's have a quick look first of all. So controls are nice and responsive. Unlike the Agilent controls, it's more like the Rigel in that we have one vertical section which does all 4 channels, and you control these by changing down these 4 buttons here, channel 1, 2, 3 and 4. Right, so let's run through just the headline numbers first of all. And again, we're going to do this with reference to the Agilent oscilloscopes, particularly the 2000 and 3000 scopes. So this has got a 2 MB memory depth as opposed to 100 kilopoints on the 2000 series and 2 meg upgradable to 4 on the 3000 series. It's got 8 digital channels if you buy the Logic Pro to go with it. The actual software itself is already installed. The 2000 has 8 Logic channels, the 3000 has 16. This has got a few little nice features like 50 ohm inputs. So the other thing this does very well, it has a very high vertical sensitivity. So this will actually go right down to 1 mV per division, and it will do that limiting the bandwidth to 100 MHz. So still very high bandwidth, as opposed to something like the Agilent, which actually has a 4 mV per division and then just zoom mode after that. So not actually capturing any high sensitivity, it's just zooming into the signal, including all the noise. In fact, this is so sensitive I can't actually show you the results here because we don't have equipment that's good enough quality to test it. But I'm relying informed, we're now going to cut to a photo. We're going to show you a 20 mV peak-to-peak signal going into the scope and 2 mV signal again peak-to-peak. So that's going to give you an idea of how sensitive this scope is. Great for analog work, and again with that and the 50 ohm input impedance, absolutely fantastic for sensitive analog circuits. So one of the big features again of this oscilloscope is the fact that it actually does serial decoding, which you can't get until you go up to the 3000 series on the Agilents. So what I've got here, we're actually just using the reference signals that we have on the front of the oscilloscope, and on this you can output lots of different signals. Currently we're outputting, we've got our chip select, we've got our clock, and we've got our data signals going through. It's got it set up. The other little feature we're going to show you, we have a scroll bar button on the front of here. To make up for the fairly small screen, by the time you've got, well, up to 11 channels on the front of it are active, you can actually, you've got a larger virtual screen and you can scroll up and down and see several things at one go. So what we've got on here, we have the decoded bus right at the bottom of the screen, data going through, decode in real time, and you can also do things like trigger off this, so it's actually very powerful and yeah, does pretty much everything you want. Lovely for doing embedded work. So what we've got set up here is just to show off the RS232 capability or decoding capability actually in a circuit. What we've got an Arduino Mega chucking a signal through, just inverting it and throwing it through to display. And what we're doing, we're sniffing that signal on the oscilloscope. And so you've got the signal here, and just along the bottom it decodes it. Welcome to what circuit? Loads and loads of options in this. If we go to the ref menu, so we can actually decode two signals at the same time. Blooming handy, especially if you've got data going backwards and forwards, or very common if you want to have data going in, data coming out, such as if you're developing a CAN or a LIN device. Very handy. So we've got bus types on here: parallel, parallel clocked, SSPI, which is a simple SPI interface, that's without the chip select line, or a full SPI interface, I2C or UART. These are bought options, but at the time these all came for free, and I believe you still get the SPI and LIN decoding for completely free, which is very nice. So in the UART display, we've got configuration, you've got your data source, active high, symbol size, parity. You can decode pretty much anything on this, including user-defined bit rates. Very nice. And you can do the usual labelling, that sort of thing. You can also display this in binary. You'd have to expand it out, but to see it, hexadecimal, decimal, and as we're currently doing here, ASCII. Works very nicely. Still very smooth on the zoom in and zoom out. One thing I should mention, we're actually triggering here off the serial itself. So here we are, triggering off serial bus. We'll show you a few of the other decodes, some of the other triggering options later. You can zoom in here, so you can trigger off the start bit, off the frame start. You can even trigger off a particular symbol, any symbol, and a particular pattern. Doing the pattern decoding is fantastic. You can set it up all up properly, and very advanced triggering. So that works very nicely. Let's just flick it back on that, back on the start bit. Right, also while I'm here I'll show you the taking the screenshot options and all the saving and recall options. So if we go into the menu, so we can save and recall all of these, so device settings, references, traces, screenshots, formularies. We're going to go into a bit more detail on that later. And you can also set up what the file print key does. This is really handy. So currently we've got it set up so it just takes a screenshot. So when you're in any menu, any setting, you just hit that and it takes a screenshot. Done. Right, so just to show you a slightly faster signal and a bit of the analysis we can do. Just find ourselves a nice quick signal out of here. So this is a 50 megahertz crystal. A little bit of loading on there, at least makes it a bit interesting. Right, so the auto measurements you have on here, we've got the quick view menu. Pass fail you see coming up on there. Quick view, very handy. Get nice, you can see the mean, the peak voltage, rise time, all of that sort of thing, all displayed in one screen. It's very nice actually. And you can also go across to the auto measure. You can just show you two different measurements down here. You can select from lots and lots of different kinds. You can see you've got all your standard voltages, peak to peak, peak positive voltage, peak negative voltage. You've got your time measurements, frequency, period, amplitude, all of these. Then going slightly bit more unusual, you can actually count the pulses, that sort of thing. You can actually measure your standard deviation, trigger frequency, trigger period. Some nice little options to measure there, but let's just get rid of that for the moment. The other thing, as standard, you've got your FFT function on here. So because of the particularly low voltage sensitivity, and the fact it's very low noise, the actual SFT works very nice. You get a very clean FFT on it. Just show you here. So that's showing us there. Let's move the cursor through a bit. Let's find that first big peak. Should be about 50 megahertz. There we are. Yeah, 50 megahertz. And you see a little bit of even harmonics there. Even odd harmonics. All comes up very nice. It's actually very usable. And we can also have a look at this to actually see the internal noise of the scope. So if we grab ourselves a 50 ohm terminator, so not quite ideal. Well, ideally you should actually just be short the inputs and watch the outputs. But as with a lot of these kind of scopes, if I just select a zero input on this, it actually just digitally zeroes the input. So you don't get to see the internal noise of the scope, it actually just draws a line on the screen. So I'm using a 50 ohm external terminator. It's almost a short. Let's see if we can see some spectral noise on there. And you can see it's actually very flat right across, up to from a very low to a very high frequency. So very, very quiet scope, and just got that proven out there. Other thing to cover while we're here, the actual physical size of this. A bit hard to tell from the scale here, but it's actually a very, very small oscilloscope. We've got a photo of this next to an Agilent 7000 oscilloscope. I'm sure we can show that in the video. And you pass me over a Rigel. There we are. As a point of comparison, that's a Rigel oscilloscope there. Very similar. Lengthwise very similar, height very similar, depth again very similar. So it's actually about the same size, but gorgeous clear screen, and being that it's a HAMEG scope, they've actually covered the front panel in buttons, as many as they can cram on there. One thing I will say about this scope and the bad points, talking about many buttons, the user interface, I think they must have fired the user interface guy, or if they haven't, they really should do. It's a classic HAMEG scope where they've got a button for absolutely everything. So once you know how to use it, it's lovely, but it's got a bit of a learning curve on it. So I'll show you some of the other triggering modes. So until now we've mostly been using the slope trigger mode. You've also seen the serial bus trigger mode. It's got all the usual ones you expect and a few more. Slope AB, pulse. The logic one's very nice, so you can trigger on a particular you can actually trigger on a particular pattern. It's quite handy. If we go to here, I'll show you some of the patterns you can do. So it's actually got a whole menu you can edit here, set up a whole pattern, and an OR gates, all of that. Very nice. Or for this particular one, let's set it to a video trigger. That's just showing you a nice analog video trigger at the moment, nice standard. We'll also show you the XY mode of the oscilloscope. So what we've done, just set it up for the absolute classic U-scope demo. Got it here. One really nice feature about this oscilloscope, which I haven't seen often before, is it actually has two windows up here, which show you both the channels in normal Y versus time mode, which is very nice. So you can actually see what's happening on the channels. Kick off U-scope there, so you can actually see the synchronization pulse on there. And you can see on here, if you actually compare this, there are videos around of this U-scope demo being done on the Agilent scopes. And you can see the waveform update rate on this, about 2,000 waveforms per second, around that, it's not as good, and it shows compared to the Agilent. So it's one of the areas where it definitely is not as good. The actual screen itself is lovely. Unfortunately, we're putting this out through a fairly low quality sound source, so it's not quite as clear as it should be. But and the screen itself, lovely. So one of the other modes this has is what's called the component tester mode. If you use an old HAMEG analog oscilloscope back in the day, I had these. Not enormously useful, but it's quite useful for educational purposes mostly. So you can produce the classic IV graphs for components. Just plug 2 formularies in the front. Set something interesting. You've got a diode here. An interesting curve like that. Let's try it the other way around. And got a classic conduction curve there of the diode. And just show you some other basic ones. There's a capacitor there. You can see the energy storage happening with the hole in the middle of the curve. Whereas something like a resistor, give a nice straight line. So very basic. Nice to see whether a simple passive component's working or not, but to be honest, not an enormous amount of use. About the only thing I have used this thing for is if you've got a big network of passive components, you can hook this up, see what the characteristics are. If you've got what should be another identical network, the curve should be exactly the same. If it's not, you know you've got a problem. But that's about it really. Nice little feature. So if the screen isn't large enough for you, this also has a DVI output on the back, included as standard, which is a nice feature. You can see here we're running into DVI monitor, standard cable, and we've hooked this up also to projector. I'm sure we'll chuck in a photo of that if you want a nice sort of 60-inch screen oscilloscope. And the other thing, using a standard passive HDMI converter, you can actually run an HDMI cable out the back, plug this into a TV, pretty much any source you like. So that's blooming handy. Just to show you the back, spin this round. So as standard it comes with this. It's got a USB interface that hooks up to the computer. It's a standard remote control, some commands, and you can control thing. You also got the RS-232, external trigger in, and a Y out. Odd that it doesn't have an external trigger out, but there you go. So one of the really big selling points of this oscilloscope is the fact that it's got very advanced math functions. And it's actually rather similar. If you ever used an old, sort of one of the old LaCroix oscilloscopes, it's actually very similar to that. So what we're doing, we're chucking in fast sine wave here, much slower sine wave here. So what we can do, nice and easy, as sort of same as almost every other oscilloscope, you've got what's called the quick math function. So you've got addition here, that's channel 1 plus channel 2, subtraction, multiply, nice bit of amplitude modulation going on there, and divide. So that's nice and basic. You can do all the standard stuff with that. So you can choose what source it comes in on, and you've got those 4 basic math functions. Now where it really gets interesting is in the full math menu. So you've got what's called formularies, and you've got 5 of those, and each formulary contains 5 equations, so you've got up to 25 equations happening here. So what you can do a whole load of analysis in the formulary, and then you can export it, save it, recall it, all of that. Each equation, you have each equation on separate lines. So if we go into here, edit this formulary, so we can edit this math1 function. We can choose whether we display it or if it's just a parameter, whether it's visible or not, and we can actually start writing bits in here. The actual functions we can do in here are enormous. If I can actually go into parameter, here we are. So we've got the addition, subtraction, multiplication, division, as you expect. Max amplitude, min amplitude, square, square root, absolute value, positive wave, negative wave, reciprocal, inverse, common log, natural log, derivative, integral, and you've got infinite impulse response, low pass and high pass filters. And then you can actually choose what frequency you roll those off at, all of those sort of bits. If we go into something with, here we are, a couple of operands, so we can have an operand of any of channel 1, 2, 3 or 4, and what's rather interesting, we've also got a constant here. Can edit this constant. We've actually also got user-defined constants, as well as e, pi, half pi, 2 pi, all the usual stuff. So this is particularly useful. What we've been using it for is actually doing things like the power loss in a resistor. So we can actually take an input of the voltage across a series resistor. We can turn that into current using division, using Ohm's law. We can then multiply that with the voltage measured across the FET. Once we multiply those two, we get the power dissipated across the FET. We can then integrate those to get the energy loss in the FET. So enormously powerful what you can do on this, absolutely fantastic. So to sum up, the user interface on this is rubbish in comparison. It could have been made so much better. Instead, it's got a really steep learning curve in it, lots of menus, that sort of thing. Once you get the hang of it though, it is very good, very powerful, and it's lovely having lots of buttons in that you can get to everything very quickly. You don't have to dive through 8 layers of menus to get there. On the upside, the maths stuff on this is absolutely fantastic, really, really powerful. And being able to do the integration, logs, all of that is really useful. And I haven't seen anything else like this on stuff in this kind of price class. The serial decode, which on this I got I2C, SPI, RS232, CAN and LIN, all free. You know, it's the 2000 series class doesn't have it on the Agilent, and the 3000 you have to pay loads to get all those options. Again, and stuff like you get the colour coding of different packets, you get start stop, all the proper triggering on there, absolutely brilliant. And comparing this to an Agilent 7000 series, which is a completely different class of scope, works just as well. It's very, very good. The other thing, you know, we've already mentioned this, but just to bring it again in summary, it's very, very electrically quiet. Very low switching noise from the power supply, and that means that it's absolutely ideal for analog circuitry. It also makes the FFT very, very good in comparison to similar scopes. You don't have the horrible noise floor that you get on some of the other ones. And just like to flag it up because it's such a brilliant idea. Don't know why more people haven't done it. The virtual screen where you can actually scroll up and down, and there's a bigger screen than the actual display shows you. Fantastic, because you've got 4 analog channels in this, 8 digital, so you have a maximum of 8 digital and 3 analog channels going at the same time. 11 channels. You need lots and lots of space if you're doing that, so it's great to be able to separate it vertically and then scroll across it. So, absolutely fantastic scope, well worth the money. It's copied Dave from the EV blog. Thumbs up. Cheers.